Today we are going to study how to interpret the results of ERGM. Uh, in the last tutorial, we studied how you could manipulate data to put it in a form where you can use ERGM. And then we saw some of the outputs of ERGM, especially outputs of two kinds, actually three kinds. The first, the diagnostics using MCMC, that is Markov chain Monte Carlo algorithms. Secondly, the summary of the object that is created by ERGM. And thirdly, the trace and density plots. Today, what we will do is try to understand how we can interpret these results. So these notes are to be read. I'm reading it verbatim. These notes are to be read in conjunction with the console output to tutorial on exponential random graph model already provided to you last week. The objective of these notes is to understand how to interpret the results of ERGM in R. It assumes that you have an understanding of the concepts of ERGM that we discussed in the class last week. We will study the R output, MC diagnostics, summary, and plot of trace and density plots. Now, this is the output of diagnostics. There is a sample statistic summary that gives the iterations, the thinning interval, number of chains, and sample size per chain. Now, we will study what these things mean: iteration, thinning interval, number of chains, sample size per chain, and so on. Then it gives the mean and standard deviations for each of the variables. Remember, in our model, the variables, the independent variables were edges, mutual ties, the gender, and the per capita income. These were the four variables, and these are the mean, standard deviation, naive standard error, and time series standard error. We will talk about these in a few minutes. Then it gives the quintiles for each variables and some sample statistics. And then there is some information on autocorrelation. We will talk very briefly about it. And second, the summary. The summary consists of the formula that we used. That is a net, depends on the edges, the mutual ties, the gender, and the per capita income. Iterations set at 20, and there are results of the simulations. Remember that these estimates are the estimates of the parameters in the ERGM model that we discussed in the class last week. And then there is AIC and BIC, that is Akaike information criterion and the Bayesian information criterion. These are used for selecting among a bunch of models that you might do the calculations for. And third, there is a plot of trace and density for the variables. Remember, there is a plot for each variable. For example, here you have trace of edges, trace of mutual ties, trace of gender, and trace of per capita income. And you also have the density plots on the right-hand side. The density plots usually look very much like a normal distribution that most of you must have studied, should have studied in one of your statistics courses before this. Let us start with the first one, the output of MC diagnostics. Remember, M1 is an object that is created by ERGM, and MC diagnostics tells us the diagnostics in the Markov chain Monte Carlo simulations. The iterations are the number of iterations that the algorithm does. There are altogether 3 million, 3 million 14,900 iterations. Remember, the colon in R means it is a sequence. It is a sequence from 15,000 to 3,014,900. So the question is, what happened to the first 14,999 iterations? Now, in MCMC, there is a concept called burn-in. Usually when you start the simulations, the first few iterations are discarded. They're called burn-ins because the statistical results do not stabilize right from the beginning. They get stabilized after a certain number of iterations. So the first few iterations are not very useful in interpreting. So the first 14,999 iterations are discarded. We only take the numbers, iterations starting with 15,000 and go all the way to 3,014,900. Remember, this 15,000 to 3,014,900 are a lot of iterations. It is a lot of data. You do not want to look at every bit of data that the simulation provides. So what you do is you sample from these after eliminating the burn-in iterations. So thinning interval 100 means that you pick a sample after every 100 iterations. For example, if you start with 15,000, you start 15,100, 15,200, and so on and so forth. Every 100th iteration is saved so you can analyze. Okay, the number of chains, Markov chains that I used is 1, and sample size per chain is 30,000. As the third bullet here shows, to conserve space, it is a good idea to thin the Markov chain in the simulations by saving every nth iteration of the simulation. In this case, the thinning interval is 100, so the sample size is 3,014,900 minus 15,000. That is the non-burnt-in iterations. Of them, you're going to select every 100th. So divide by 100, 30,000. So the sample size per chain, there is only one chain here, is 30,000. The first bullet, ERGM uses Markov chain Monte Carlo simulation. It is a good idea to discard the initial burn-in. I've already talked about it, since it is unlikely that they come from a stationary distribution. Hence, the iteration starting at 15,000.